Okay, let us now discuss question number 23. We have discussed up to question number 22. Now let us discuss 23. Question number 23 says a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeters and the height of the cone is equal to its radius. Okay. Find the volume of the solid in terms of pi. Okay, so what the question says is that there is a solid which is in the shape of a cone and that cone is standing on a hemispherical base. So let us try to sketch the diagram for this question. This is question number 23. There is a cone like this, and this cone has a base. It is standing on a hemispherical base like this. Okay, this is hemispherical base and this is the cone, and what it says is with both their radii being equal to 1 centimeters, it means their base is exactly same, their base is overlapping with each other, and the radii of the base is, this is the radii, this radii is 1 centimeters. Okay, the radii of this base is 1 centimeters. Further it says, and the height of the cone is equal to its radius. Okay, so what is the radius of the cone? Here we can see it is saying that radii of both cone and hemisphere are equal. It means the radii of cone, the radius of cone is definitely 1 centimeters, which is same as of hemisphere. So I can say the height of this cone, okay, this height is also 1 centimeters, because it says that and the height of the cone is equal to its radius. It is not equal to the diameter, it is equal to the radius of the cone. Radius of the cone is 1 centimeter, so definitely height is also 1 centimeters. Now we need to determine the volume of this solid in terms of pi. So what is the volume of this solid? If I talk about volume of this solid, then this volume of solid is equal to volume of cone plus volume of hemisphere. Why? Because this solid is made up of a cone as well as a hemisphere. So whatever be the amount of water that can be contained in this solid will be equal to the amount of water contained in this cone plus amount of water contained in this hemisphere. Okay, so that must be the total volume or the total amount of water that can be contained inside this solid. So now what is the volume of cone? We know the volume of cone, it is 1/3 pi r square. Radius square is 1 into h is again 1. This is 1/3 pi r square h is the volume of cone plus volume of hemisphere. It will be 2/3 pi r cube. R is 1 and this is cube. So this is pi by 3 plus this is 2 pi by 3. So pi by 3 plus 2 pi by 3 is equal to pi centimeter cube. Okay. So the volume of this particular solid is pi centimeter cube. So this is what we have to determine, because it is told in the question that you need to determine the volume in terms of pi. Okay. So exactly pi centimeter cube is the volume of this cone. Okay, so this is the solution for 23rd question. Let us move to 24th one. Question number 24 says, a juice seller was serving his customer using glasses as shown in the figure. The inner diameter of the cylindrical glass was 5 centimeter, but the bottom of the glass had a hemispherical raised portion which reduced the capacity of the glass. If the height of a glass was 10 centimeters, find the apparent capacity of the glass and its actual capacity. Okay, so what it says is, a juice seller was serving his juice in some glasses, and obviously the glasses are of cylindrical in shape. So in that cylindrical glass, what it says is there is a raised hemispherical portion in the bottom as given in the figure. So let us draw the diagram for this question. Like this. This is the glass, okay, this is the cylindrical glass. It says the inner diameter of the glass was 5 centimeters. So the diameter of the glass, that is inner diameter, is 5 centimeters. So what about radius? Radius will be 5 by 2 centimeters. Okay, the radius of this glass is 5 by 2 centimeters. Further it says, but the bottom of the glass had a hemispherical raised portion. It means in the bottom the glass should be a perfect cylinder, but what happens is the glass is not perfect cylinder, there is a raised portion, there is a hemispherical raised portion at the bottom of the glass. So this part of the glass is not available to fill the juice. The glass is something like this. Okay, because this is a hemispherical portion which is raised. Now because of this volume of hemisphere, okay, whatever be the volume of this hemisphere, this much volume will be left out. Okay, it means in this volume I cannot fill juice. Why? Because it is raised internally. So what it says is, in this glass, because of this raised hemispherical portion, the capacity of the glass is reduced. Obviously it will be reduced because this much volume will be wasted. Okay, you might have seen the glasses in which there is a design at the bottom, or it's a raised portion at the bottom. It is just to reduce the capacity of the glass. Okay, or maybe sometimes just to have a good looking for this glass. Now what it says is, if the height of the glass was 10 centimeters, so height of the glass is also given to us, which is 10 centimeters. Okay, in this 10 centimeter high glass, this is a hemispherical raised portion. Further it says, find the apparent capacity of the glass and its actual capacity. Now what is apparent capacity? Apparent capacity means the capacity which appears, okay, the false capacity which appears to us that it should be the capacity, but in actual it has this raised hemispherical portion. So due to this the capacity of the glass will reduced. So what we will say is that the apparent capacity means the actual capacity that this glass should have, okay, without this hemispherical portion. But in actual we have this hemispherical portion, so the real capacity will be less. How much less? The real capacity will be volume of this hemisphere. Okay, we will deduct this volume of this hemisphere from the apparent capacity to get the actual real capacity. Why? Because in this hemispherical raised portion I cannot fill juice, so this portion will be wasted. So what I want to say is that if I talk about apparent capacity, apparent capacity is capacity of glass which appears from outside, or which is a false capacity. Okay, the appearing capacity, it's a delusion. So this apparent capacity is basically capacity of glass without hemispherical raised portion. Okay, it's the capacity of the glass without that raised portion. So just imagine if we do not have this raised portion, I can see that this glass is a perfect cylinder with its radius as 5 by 2 centimeters and the height of 10 centimeters. So what should be the capacity of this glass? Capacity means volume. So volume of this glass, or in bracket I can write apparent, is equals to pi r square h. Okay, that is pi into 5 by 2 square into 10 centimeters. Okay, this much centimeter cube is the volume of this glass, or this much ml is the volume of glass, because previously I have told you that 1 ml is equal to 1 centimeter cube. Okay, let me write that conversion again. 1 centimeter cube is 1 ml. Why this is so? Because 1 liter is 1000 centimeter cube. This is a conversion. Okay, you need to remember this conversion. That's why I can say this much is the, in ml, this is the capacity of the glass, that is apparent, that is just appearing from the outside. Now since this is the apparent capacity, so we have calculated the apparent capacity. Now how much volume should we deduct from this? The volume to be deducted from apparent volume is equal to what? We need to deduct the volume of this hemisphere. Now volume of this hemisphere will be what? It will be, I can see this hemisphere and this glass has the same internal radii because it has the same base. Okay, this hemisphere is taken out from the glass itself, that's why I can say the radius of this hemisphere is also 5 by 2 centimeters. So if radius is 5 by 2 centimeters, then the volume of the volume to be deducted from the apparent volume, or should be subtracted from the apparent volume, is equal to the volume of hemisphere. Okay, hemispherical raised portion. It is equal to what? It is 2 by 3 pi r cube, that is 5 by 2 whole cube. Okay, this much volume in centimeter cube or in ml. Okay, in centimeter cube, I will write ml in the last. Okay, so this much volume should be deducted. So what should be the real capacity of the glass? The real capacity of glass is equals to the apparent capacity minus the false capacity, minus the capacity of that hemispherical raised portion. So it will be pi times 5 by 2 square into 10, okay, minus 2 by 3 pi 5 by 2 cube. This much is the capacity of the glass in milliliters, okay, or in centimeter cube. So you need to solve this question. So this much ml of juice can be contained in this glass, okay, or else if we do not have this hemispherical raised portion, then this much juice, this much amount of juice can be contained in this glass. So what the shopkeeper has done is, the juice seller has saved this much amount of juice. Okay, if the question says that how much ml of juice the juice seller has saved, okay, or cheated, so we can say this much volume of the juice the juice seller has cheated or saved. Okay, so this is the solution for question number 24. It's very easy question, but there are some more questions which can be taken out from the same question. What we can say is, if the question says that how much juice he cheated or how much juice he saved or how much less amount of juice you got when you drink in this kind of glass. Okay, so question can be twisted in any form. So you just need to remember the concept that I have applied, or else you will not be able to solve the question which comes twisted on the same concept. You do not need to mug up these concepts. Okay, just try to understand each and everything. I have written each and everything, okay, in words, so you can note this. So first you note these two questions, then we will continue. Okay, let us now solve question number 25 from the practice sheet. Question number 25 says, a solid iron pole consists of a cylinder of height 220 centimeters and base diameter 24 centimeters, which is surmounted by another cylinder of height 60 centimeters and the radius 8 centimeters. Find the mass of the pole given that 1 centimeter cube of iron has approximately 8 gram of mass. Okay, so what question says is that there is a solid iron pole, okay, which has the height of 220 centimeters and the base diameter as 24 centimeters. Now on the top of this iron cylinder or this iron pole, there is another cylinder which has a height of 60 centimeters and the base radius of 8 centimeters. Okay, and it is also made up of same iron. Further it says find the mass of the pole. So we need to determine the mass of the pole, and it is given that 1 centimeter cube of iron has approximately 8 grams of mass. Okay, so let us understand the basic concept. Question number 25. It says that this is an iron pole. This is an iron pole, okay. It has the height of 220 centimeters and the base diameter as 24 centimeters. Okay. Now, further on this iron pole there is another iron pole which is located at the top of this iron pole, like this, and this iron pole has a height of 60 centimeters and the diameter as okay, the radius of this iron pole is given. Let us take the diameter, which is 16 centimeters. Okay, the diameter is given and the base radius is given. Now for determining the mass, let us see the relation between the mass and the volume. It says that 1 centimeter cube of iron is equivalent to 8 grams iron. Okay. Now what does this mean? 1 centimeter cube of iron is equivalent to 8 grams of iron. It means if I take a iron cube of 1 centimeter cross 1 centimeter cross 1 centimeter, if I take an iron cube which is of 1 centimeter in length, okay, height and width, then the mass of this iron cube is 8 grams. Okay, क्या मतलब होता है इस 1 सेंटीमीटर इज इक्विवेलेंट टू 8 ग्राम्स का? इट मीन्स अगर मैं इस आयरन का 1 सेंटीमीटर क्रॉस 1 सेंटीमीटर क्रॉस 1 सेंटीमीटर का एक क्यूब लेता हूं तो उस क्यूब का मास कितना होगा? 8 ग्राम्स. मतलब अगर उस क्यूब का मैं वेट करूंगा, वेइंग मशीन पे रख के उसका वेट करूंगा, सो द रिजल्ट विल बी 8 ग्राम्स और अप्रोक्सीमेटली 8 ग्राम्स. This particular conversion, this particular value, this relation is known as density. Okay, इसे ही हम density भी कहते हैं. What is density? Density is mass per unit volume. Okay, डेंसिटी का मतलब होता है मास पर यूनिट वॉल्यूम. नाउ फ्रॉम दिस what it is given that 1 centimeter cube of volume is equivalent to 8 grams of mass. It means the density of iron we call density of iron as 8 grams per centimeter cube. Okay, the mass per unit volume, that is density, is equals to mass upon volume. This is a basic conversion. Okay, this is a very basic concept of density. So you need to remember this concept because this is applicable in mathematics as well as in physics as well as in chemistry, okay, as well as in biology and many other fields. So this is the concept of density that we need to use, since it says we need to calculate the mass of this particular solid figure. So definitely for calculating the mass I need volume. Okay, so what this question says, indirectly this question says that please calculate the volume of this solid figure. ये क्वेश्चन हमें इनडायरेक्टली कह रहा है कि आप इसका वॉल्यूम कैलकुलेट कीजिए, बिकॉज वॉल्यूम से ही मास कैलकुलेट होगा. सो ट्राई टू अंडरस्टैंड द अप्रोच, ट्राई टू अंडरस्टैंड द रिलेशन. मास कैलकुलेट करना है, मास किससे रिलेटेड है? मास रिलेटेड है वॉल्यूम से. इसका मतलब इस पर्टिकुलर सॉलिड फिगर का वॉल्यूम कैलकुलेट करना है. So now what is the volume of this particular solid figure? I can see that this solid figure has two different components. First one is this solid bar, this cylindrical solid piece of iron, okay, and second one is this cylindrical solid piece of iron. So I can say volume of solid figure is equal to volume of iron, or let us name these two figures as, let us name this as cylinder 1 and this as cylinder 2. ओके, द बिगर वन, जो पार्ट नीचे है, जो नीचे वाला सिलेंडर है, जो बड़ा सिलेंडर है, उसे हमने सिलेंडर 1 नाम दे दिया, और जो ऊपर वाला सिलेंडर है उसे सिलेंडर 2 नाम दे दिया. सो द वॉल्यूम ऑफ सॉलिड फिगर विल बी वॉल्यूम ऑफ सिलेंडर 1 प्लस वॉल्यूम ऑफ cylinder 2. Okay, so what will be the volume? Volume will be volume of solid volume of cylinder 1. The volume of this cylinder will be pi r square h, because cylinder का volume का जो formula है, that is pi r square h. For that, what is the height of this cylinder? It is 220 centimeters. What is the radius of this cylinder? The diameter is 24, so the radius will be half of this diameter. So we call this as 12 centimeter, which is the radius of this bigger cylinder or cylinder 1. Okay, so the volume of cylinder 1 will be pi r square is 12 square into h, which is 220. This is the volume of this larger solid figure, larger cylinder, plus the volume of second solid figure, volume of this solid figure, this cylinder. The radius will be, radius is given as 8 centimeters. Okay, the height of this solid figure is 60 centimeters. So the volume will be pi r square is 8 square into 60 centimeters. Okay, so this is the volume of this cylinder in centimeter cube. Okay, of this solid figure. This is the volume of this solid figure. Let us name this volume as Vs. Okay, Vs represents the volume of this complete solid figure. Now what will be the mass of this solid figure? I can see that it says the mass of 1 centimeter cube of iron is 8 grams. So the mass of this Vs centimeter cube of iron will be Vs into 8 grams. So what my task is? My task is just to solve this, take the value of Vs and multiply it by 8 to get the mass of this iron figure. Okay. So here I can write this mass will be Vs. In place of Vs I can write pi into 12 square into 220, okay, plus pi into 8 square into 60. This is the mass of, this is the volume into 8. This much grams is the mass of this iron figure. Okay. So in this question we have learned this concept of density. Okay, this is the density of this iron. So this is the meaning of density, and this is the formula for density, and this is the unit of density. We have discussed each and everything about density further. So this is the solution for question number 25. Okay, so you note this, then we will continue. Okay, now let us discuss question number 26. Question number 26 is, Geeta was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminium sheet. The diameter of the model is 3 centimeters and its length is 12 centimeters. If each cone has a height of 2 centimeters, find the volume of air contained in the model that Geeta made. Assume the outer and the inner dimensions of the model to be nearly the same. Okay, so let us understand this question. It says that the Geeta was asked to make a model. Okay, the model is shaped like cylinder with two ends as conical. Okay, the model is, there is a cylinder and at the two ends of the cylinder there are two cones. Further it says the diameter of the model is 3 centimeters. Now this model is made up of aluminium sheet. Okay, so aluminium sheet is very thin. What it says is the diameter of the model is 3 centimeters and the length is 12 centimeters. If each cone has the height, so height of the cones at the ends is also given, which is 2 centimeters each. We need to determine the volume of air contained inside the model, and for that we need to assume that the inner and outer dimensions are same. So what does this mean, that we need to assume inner and outer dimensions same? It means that we need to take that aluminium sheet is very thin. Okay, it do not matter that if the outer diameter is 3 centimeters, then inner diameter will be less. Okay, it might be less with some point only. Okay, or approximately we can take it as same. What does this mean is, for example, if the diameter of this cone, this solid figure, the outer diameter of this model is 3 centimeters, let us assume that the aluminium sheet has a thickness of 1 mm or 2 mm. Okay, so it is not very large thickness, so we can neglect the difference between the inner and outer diameters. We can assume that inner diameter and the outer diameter are same. So this is what is meant by the information given in the bracket. Okay, assume that the outer and inner diameter. So you can write here that this bracket information, it means, it implies that aluminium sheet is very thin. Okay. Now let us understand the question. Let us try to sketch this question. Question number 26. The model is in the shape of a cylinder. So first let us make a cylinder like this. This is the cylindrical model. On this cylindrical model, there are two cones at two ends. So I can assume this as the axis of the cylinder. Axis means the line joining the centers of top and bottom. So let us say this is the cone. Okay, this is the cone. I can take this cone has of height something like this. So these are the two cones attached at the two ends of this cylinder. Now further it says that the diameter of this model is 3 centimeters. So let us mark the diameter. This is the diameter. This is 3 centimeters and the length of this model is 12 centimeters. So the length of this model will be this one. Length will be from end to end. This is one end and this is second end. The apex of the two cones, this is 12 centimeters. This is 12 centimeters. This is the length of the cone. Then the height of the cones are also given. The height of the two cones is 2 centimeters each. Okay. It says height of each cone is 2 centimeter each. So height of this cone is also 2 centimeters. Okay. So if total length is 12 centimeter, 2 centimeter is deducted from this end and 2 centimeter is deducted from that end. So the height or the length of this cylinder will be 12 minus 2 that is 8 centimeters. Okay. This is what we can deduce from the figure. Now as the diameter is 3 centimeters, so what will be the radius? Radius will be 3 by 2 centimeters. Okay. Now we need to determine the volume of air contained in this solid or volume of air contained in this model. So volume of air contained will be what? It will be similar to volume of model. So what it's simply asking is just calculate the volume of model. This is what the question is. Okay. It is just given for confusing students that volume of air contained or volume of water that can be contained inside, or how much water can be contained inside the cylinder, or how much fuel can be contained in this model, and all these questions. These are the same questions, just to confuse the question, just to make it a bit difficult to understand. This twist is given to the question. Okay. So simply we need to calculate the volume of model. That is the only question. So volume of model will be equals to what? It will be volume of left cone plus volume of cylinder plus volume of right cone. Okay. The two volumes, let us say this is the left cone and let us say this is the right cone. Now what is the volume of left cone? Volume of a cone is 1/3 pi r square h. So 1/3 pi r square h is the volume of this cone. 1/3 then pi. What is the radius? Radius is 3 by 2. Why? Because the cylinder and the cone have same base. Okay. The overall diameter of the model is 3 centimeters. Okay. So this base is also 3 by 2 in radius. Okay. So volume of this cone will be 1/3 pi into 3 by 2 square into h. H is 2 centimeters. So volume of left cone is 1/3 pi, r square is 3 by 2 square into h is 2 centimeters, plus volume of cylinder, it is pi r square h. Pi into r square is radius, again 3 by 2 centimeters, and h will be this time 8 centimeters. So plus pi r square is 3 by 2 centimeters into 8 centimeters. So pi r square h plus volume of this right cone, it will again be same, which is 1/3 pi 3 by 2 square into h, which is 2. So just add these two values. This will give you 1/3 pi r square. This is also same. So this will be 2 times 2 by 3. 2 by 3 into 2 will be 4 by 3 pi 3 by 2 square. Okay, plus 8 pi into 3 by 2 square. So if you take pi into 3 by 2 common, pi into 3 by 2 square common, this will give you 8 3s are 24 and 4 is 28 upon 3 in centimeter cube. Okay, this will be the volume of this model. Only the twist is just to understand that the length, the thickness of this aluminium sheet is negligible. Okay, this thickness of this aluminium sheet is negligible, we can neglect it very easily. So this is the solution for question number 26. Okay, so you can note this, then we will continue further.